Already we have seen constant m and constant n circles. If you plot a constant m n circles in a decibel scale, then it is called Nichols chart. Nichols chart also we have seen. Today let us see sums on Nichols chart. Then we will go to that final part, that is state space analysis. That is 50 unit. The next unit is state variable analysis. Already I told you that it is extension of first unit. Extension of first unit. In the first unit, we have seen mathematical model of mechanical systems, electrical systems. How to represent the mathematical model in state space is called state variable method. What is the drawback in transfer function model? So far, we have seen only transfer function model. Transfer function, while finding transfer function, what we are assuming that zero initial conditions, zero initial condition. It means what? Suppose you are taking a mechanical system, it's initially it is at rest. The velocity is zero. Initially, its acceleration is zero. Its velocity is zero. It is at rest, like that we are taking. If it is electrical system, there is no voltage, no current initially. Like that we are assuming. If we assume like that, the capacitor, no voltage. In the inductor, no current. Like that we are assuming. That is, initial conditions are zero. Like that we are assuming, we are finding transfer function. The drawback is, if you assume initial conditions, it's not possible to find the transfer function. That is the drawback with the transfer function method of representation. Second drawback is it describes only the relationship between input and output. What is the transfer function? T of s, G of s equal to Laplace transform of output by Laplace transform of input. That is the transfer function. K upon tau s plus 1, first order system. It is the relationship between input and output. Only two variables are involved. One input, one output. That's all. Suppose in a car, many variables are there. The engine temperature, car speed, engine temperature, and the fuel. How much fuel is reduced? How much fuel is flowing into the carburetor? So many things. How many fuel is injected into the engine? Like that, there are many variables are there. But in a transfer function model, that is SISO system, we are considering only output and input. In a car, how we modeled the speed versus acceleration, input acceleration. Like that we model. We cannot consider other variables in transfer function model. That is, this transfer function is limited to SISO system, single input, single output system. That is the drawback. And it is applicable only for time invariant system. Time invariant system. This is tau is constant. This tau is constant. Constant. The K is constant. K is constant. If you assume like that, then only you can find the transfer function. So it is time invariant. It is not time variable. Time invariant system. So these are the drawbacks with the transfer function model. That's why we are going to state variable model. In state variable model, you can consider, for example, in a MIMO system, if you consider MIMO system, how many inputs are there? M inputs are there. In this case, M inputs are there. How many outputs are there? P outputs are there. Outputs are there. P outputs are there. Y1, Y2, Y3, Yp up to. Inputs are U1, U2, U3, Um. You cannot represent this in transfer function model. You can take U1, you can find Y1. All other variables are disturbance like that. You can assume a system. The system is SISO system, and that one input, one output. That's all. Here in state space model, you can assume n number of inputs, n number of outputs. That is possible. If you represent that, then each state variable, each variable that you are considering, what are the state variables you are considering? X1, X2, X3, etc., Xn. Because it is nth order nth order system. Therefore, n state variables will be there. If it is nth order system, n state variables there. If it is fifth order system, 5 state variables will be there. So the number of state variables equal to the order of the system. Each state variable, x1 is a state variable. For in a car example, x1 is speed of the car, x2 is engine temperature, x3 is how much fuel is at present there. Third one is that is also important. How much fuel is there? Also important. In a rocket system, if rocket is going up and up, the fuel is decreasing. Therefore, the weight of the vehicle, the weight of the rocket system is decreasing. Finally, it is went to orbit means what is the fuel? Fuel becomes zero. That's why we have to take that into account. In that case, you can consider weight of that fuel also. That is third variable. Then what is the amount of fuel injected? What is the velocity of fuel injected into the system? That also you can take another variable. Like that, many variables are there. It's a derivative of each variable. Derivative means what? Velocity. Velocity of x1, velocity of x2, velocity of x3, like that. That can be written as function of, all state variables, x1, x2, x3, x4, etc., xn, and all inputs. What are the inputs? How many inputs? The m inputs. u1, u2, etc., um. You can write as a function of x1 dot can be written as a function of x1, etc., xn, comma, u1, etc., um. Like that we can write. x2 also can be written the same way, but it is another function, f2 function. xn can be written as another function, f1. If you write like this, then it is represented in state variable form. State variable form. Now, what is the definition for state variable? Here, the number of state variables here is n. That is the minimal set. You cannot find n minus 1 or n plus 1. That is not possible. You cannot find n minus 1. You cannot, if you take n minus 1 state variables, then if you take n minus 1, it is not, the system is not completely specified. The system is not completely specified. For example, the weight of the fuel is not considered, means the system is not completely specified. At any instant, you cannot completely specify the system because weight is reducing as the vehicle goes up. Here, vehicle, I'm saying that the rocket going up, the fuel is decreasing. That's why weight is decreasing. That's why you should consider weight of the fuel. Then only it is complete definition. Suppose you are leaving one variable, means the system is not completely specified. If you take additional variable, means suppose I'm adding two variables. For example, I'm finding the third variable as speed of a rocket you are taking. In addition, you are taking some other variable, say a combination of two variables, engine temperature and surface temperature added together. That is one variable. Like that, if you take means, you will get n plus 1. So, only n is possible. Prime variables, x1, x2, etc., xn, like that, you will get prime variables. If you find n plus 1, it is not prime. N minus 1, it is not completely specified. This is over specified. This is under specified. So you have to take n state variables. That's why it is called the minimal set of variables. The number of variables equal to the order of the system. Number of variables equal to order of the system. Number of state variables equal to state variables equal to order of the system. It is nth order system, means n state variable will be there. What is the definition for state variable? The state of the system is a minimal set of variables, minimal set n variables, such that the knowledge of these variables at a t equal to t naught, initial time is t equal to t naught. No need to take t equal to 0. In transfer function model only we have to take t equal to 0. Here t equal to t naught, together with knowledge of the inputs at t greater than or equal to t naught, After T naught, I know all inputs. Then it completely determines the behavior of the system after T greater than or equal to T naught. After T, I am starting at T naught. At T naught, I know what are, after T naught, what are the inputs I am applying, I know. Then I can find the state of the system, x1 to xn, at any point. At any point. Then the x1 to xn are called state variables. The state of the system is minimal set of variables known as state variables, such that the knowledge of these variables at t equal to t naught, together with the knowledge of the inputs for t greater than or equal to t naught, completely determines the behavior of the system t greater than or equal to t naught. After t naught, it completely specifies the system. Now, let us take a third order system, g of s equal to, let us take the second order system or third order. Okay, let it be third order. S cube plus a s square plus bs plus c. What is the order of the system? Third order. So if you, what is the g of s? G of s is x of s upon u of s, where x of s is the output, u of s is the input. If you cross multiply, what you will get? Cross multiply k u of s equal to x of s multiplied by s square s cube plus a s square plus bs plus c. Or I can say that s cube means what? I want to write in time domain. K u of t. Time domain u of t. U of s becomes u of t. S cube means third derivative. D cube x by dt cube. This is s cube. Plus a s square means second derivative. D square x by dt square. Plus b dx by dt plus cx. So this is the differential equation. This is the differential equation. For that, we obtained the transfer function like that. So this can be written as in state space model. How I am writing? Let us see. Let us assume that x equal to x1. X equal to x1. As you are assuming, I am giving new variable name x1. X equal to x1. X is the output. X is the output. X is output. I am finding another output, that is state variable x1. X equal to x1. x1 dot equal to x2. I am writing x1 dot equal to x2. First derivative of first variable is called second variable x2. Second state variable x2. x2 dot equal to x3. I am defining like that. x3 dot equal to x3 dot equal to, since it is third order, that's why I'm stopping here. Otherwise, I can write like this continuously. I'm assuming that x1 dot equal to x2, x2 dot equal to x3, x3 dot equal to question. Here, this can be written as keep these d cube x by dt square one side and keep all other variables on the other side. What you will get? D cube x by dt square equal to k u of t minus a d square x by dt square minus b dx by dt plus cx. Can I write like that? Huh? So d square x by dt cube minus, no, it is on the other side already. K u of t is on the other side, no? Yes, cx is minus. You are saying correct. Thank you. Minus cx. Minus cx. So now what we assumed? X equal to x1. That's why we can write this as cx1. What is dx by dt? Minus b x1 dot. What is a d square x by dt square? X1 double dot minus k u of t equal to x triple dot. Am I correct or not? All are derivatives. We can write like that. X double triple dot of t equal to k u of t minus a x1 double dot b x1 dot c x1. But x2 equal to x1 dot. That's why I can write this as, I am writing c x1 as such, but x1 dot is x2. That's why b x2 I am writing. Can I write like that? X1 double dot can be written as x2 dot because x2 dot derivative of x2 dot is x1 double dot. X1 double dot. X2 dot, sorry. X2 dot is x1 double dot. Am I correct or not? Because x2 is what? X1 dot. If you differentiate one more time, you will get x2 double dot. So x3 dot is x1 triple dot. X3 equal to what? X2 dot. X2 dot equal to x1 double dot. That's why x1 triple dot is x3 dot. X3 dot equal to x1 triple dot. So now x is x1. Already we defined x is x1. Therefore, x1 dot can be written as x2. X1 double dot is what? X3. So minus ax3. ax3. Am I correct? X1 double dot equal to what? X1 double dot equal to x3. X1 double dot equal to x3. If you want to remove dot, you have to write one number ahead. That's all. X1 dot equal to x2. X2 dot equal to remove x3. Like that. You have to remember. But x2 dot can be written as x1 double dot. X1 double dot. X3 dot is x1 triple dot. X2 equal to x1 dot. So we can write k u of t. X triple dot. X triple dot. Now substitute here. The question mark can be substituted from here. Minus ax3 minus bx2 plus cx1. The left hand side you see all derivative. Right hand side you see all non-derivative. Right hand side only variable. Left derivative is only in the left hand side. That too first derivative only. So I wrote this third order equation. If you write in time domain, what you are getting is third order differential equation. Now I broken this into three first order equations. Third order equation is split into three first order equations. What are the three first order equations? X1 dot equal to x2. X2 dot equal to x3. X3 dot equal to k u of t minus ax2. X3, sorry. ax3 minus bx2 cx1. That's all. So the third order equation becomes three first order equations. So if you put this in matrix form, x1 dot, x2 dot, x3 dot equal to, I am putting all these constants. What is the coefficient of, I am taking state variables outside, x1, x2, x3, state variable, plus input, another state variable. Input also I am writing separately. I will explain. U of t, k u of t. Here, what is the first equation? X1 dot equal to 0x1, 0, 1x2, 0x3. Second equation, 0x1, 0x1, 0x2, 1x3. Third equation, minus cx1, minus bx2, minus ax3. So I put this in matrix form. If you multiply, you will get these three equations. How to you will get in how to multiply these two? Take first row, first column. 0x1. This can be written as 0x1 plus x2 plus 0x3. This can be written as 0x1 plus 0x2 plus x3. The third equation, this can be put in matrix form. Here in the third equation, you are having plus 0 u of t plus 0 u of t. Here, k u of t. That's why here only we are having k. Here only you are having first two equations 0 u of t. I put this in matrix form. Third degree equation, third order equation is written in matrix form. This is called state space representation. This representation is called state space representation. I am breaking the third order equation into three first order equations. Therefore, in the mathematics, you are having plenty of matrix manipulations. All matrix manipulations can be applied to differential equation. That is the advantage of writing this into three first order equations. So a third order differential equation is written as three first order differential equations. So this is state space. If it is nth order, means what is the equation? Nth order means T of S equal to K upon, how we will write Tn S power n plus, An S power n, An minus 1 S power n minus 1 plus etc. plus A naught. Like that you will write. If you write this in state model, you will get x1 dot, x2 dot, x3 dot, x4 dot, etc. xn dot equal to, you will get A matrix. Here you got an A matrix, A11, A11, A12, etc. A1n. Here A21, A22, etc. A2n, etc. an1, etc. ann. You will get n matrix elements. Here what you will write? Integral of this value. What is the integral of this state variables x1, x2, etc. xn you will write. Plus you will write m input variables. B11, B12, B13, etc. B1m, etc. Bn1, etc. Bnm. You will get a B matrix multiplied by U of t. This also many inputs, say U1, U2, U3, etc. Um of t. So many inputs. This is a state space representation of nth order system. How many inputs? M inputs. We can write these state variables in the outputs are P outputs we have seen. How many outputs we have seen? P outputs we have seen. How to write these P outputs? Y1, Y2, etc. Yn, Yp equal to a matrix. Here, C matrix, that is x1, x2, x3, etc. xn plus the same d11, d12, etc. d1m, dnm, dnm. Here u1, u2, etc. This is how many? How many dpm? How many rows will be there? Only p rows. Here x c11, c12, etc. c1n, etc. cp1, cp2, etc. cpn. Here d1, dpm. Here also dpm. What is the dimension of the C matrix? Number of rows equal to P by N. What is the dimension of this? Number of rows equal to P by M. What is the dimension of the state variable? N by N. What is the dimension of this? N by M. So dimension of A matrix is N by N. This matrix is called A matrix. A matrix. This matrix is called B matrix. This matrix C matrix, D matrix. Therefore, I can write the state model as x dot, capital X dot equal to A matrix multiplied by X plus BU. Like that I can write, where X is a state variable matrix. Y equal to CX plus DU. Cx plus du. This is output equation. This equation is called output equation. This equation is called output equation because it gives output. This is called state equation. State equation because it gives state variable. State equation. These two together is called state space model. State space model.